All right, so as of right now, this is going to be our last video. Okay, if you guys need any more solutions, feel free to email me or send me a message on Remind. I'm going to do 2 of these practice problems. The reason I'm only doing 2, even though there is 8, is so that you guys can use either method. I'm going to teach 2 different methods. I'm going to do number 1 using the triangle method and number 3 using the components method. Okay, so I'm going to teach you guys both of them, and then you guys are free to pick what method you prefer, and you can use them for the rest of them. I will post the solutions, the actual answers later. If you have any questions, feel free to message me. So, number 1. All right, a silly boy throws a water balloon at an angle of 35 degrees toward his sister who is standing 10 meters away. So first thing, let's draw it. We got the boy. We got the girl, right? His sister. He throws a water balloon at her, right? We're going to draw the path of the water balloon, and it's going to hit her, okay? So let's write out our assumptions. Assume no air resistance, right? If we assume no air resistance and assume up is positive, down is negative, and then right is positive, left is negative, okay? Then we're going to write out the rest of our knowns. We know that it was at an angle 35 degrees. And we know that the displacement is going to be 10 meters per second. We do not know the V initial. We do not know the V final. We do not know the max height. And we do know acceleration. Acceleration, this is in free fall, so 9.81 meters per second. Right? And then our time. We do not know our time. We can solve for all of this, right? So first things first, let's do our triangle. So we know that the boy threw it at an angle of 35 degrees above the horizontal. We know that acceleration was downward. So this is V naught t. And then we know that from beginning to end, this was our displacement, right? So this would be our triangle. Our triangle is like this. So let's go ahead and plug in what we know. We know that displacement is 10. We know that the angle was 35. And we know the acceleration was 9.81. In this one, we don't have to put our negative because it's a vector. So the direction of the arrow already takes into account the fact that it's negative. So t squared, and then we have V naught t. Okay? So using SOHCAHTOA, what do you think we could solve for? Right? On this side, we're missing 2 variables, right? Over here, we're missing 1 variable, and here we're missing no variables. So first thing we should probably do is solve for time, right? And we could do that using trig. So we can use SOHCAHTOA. Okay? Using trig, right? We know that we have the adjacent and we're missing one of the hypotenuse. So we can use tangent. So let's do tangent of 35 is equal to opposite. So half a t squared. So half 9.81 t squared over 10. Let's do a little bit of math, right? Some algebra. We get 10 tan 35 over times 2 divided by 9.81 equals t squared, square root. I went a little fast because you guys should be advanced in math. If you need any help with that, go ahead and message me and I'll go back through it slow. Okay? So what we're going to do now is we can plug this whole thing into our calculator. We'll do square root of math frac 2 times 10 times tangent 35 over 9.81. Make sure that we are in degrees. And when we hit enter, we end up with the time that it took for this balloon to hit the sister was 1.195. Oops, it's not a 5 seconds. Okay, so it took t equals 1.159 seconds to hit the sister. So we were able to solve for t. Now that we have this information, can we plug straight into our equations? Our d equals v naught t plus half at squared, and a equals change in velocity over time? No. And the reason is because these are vectors. And we know that 5 plus 5 is not 10 in this class. So the next thing we would do is, now we know our time, we can plug it in here. And now what we can do is we can solve for v naught. We can solve for v naught using cosine. So cosine 35 is equal to 10 over v naught. Our t is 1.195, right? So do a little bit of math. We're going to end up with v naught equals 10 divided by cosine 35, 1.195, right? So if we were to solve for v naught, we would end up, we could plug this all into our calculator. Clear math frac. 10 over cosine 35 times 1.195. And we're going to end up with our v initial was actually 10.216 meters per second. That would be our v initial. So 10.216 would be our v initial. Now, since, remember we talked about when it goes, something goes up and it goes right back to the same point, the v initial is equal to the v final. One's just negative. Same thing for 2D motion. The same amount of time you went up is the same amount of time you went down, right? So we hit a max point, we went back down. That means that the v initial is equal to the v final in a perfect parabola. And in this situation, we started and ended at the same height, so we had a perfect parabola, which means that our v final would also be, so v initial went this way, v final would be this way. It would also be 10.216 meters per second. Okay? And instead of putting negatives or positives, we just show the direction that it's going in. So this would be also 10.216. Now we were able to solve for all those unknowns. Now we got to figure out this thing called max height. So when we hit max height, I'm going to draw the triangle. So if this balloon were to move, and then we would stop it at the top, our v initial would go up. We would have half at squared up until the point that it stops, and then we would have our displacement. Our displacement will now end at the top because we have a height that we have displaced, right? Now, you can choose to solve it using trigonometry, but usually I suggest, when it comes to max height, solving using components. So we know that at max height, according to our lemon problem that we did before, the v final is only, our v final in the y is 0. So our v final is equal to the velocity in the x initially. So what we're going to do is we're going to break down our what's it called? We're going to break down our initial velocity. Our initial velocity was 10.21, but it was moving at an angle of 35. So we're going to solve for the v initial in the x and the v initial in the y. And we're going to use that using SOHCAHTOA. So sine is opposite. So if we do sine 35 times our hypotenuse, right? So sine 35 times our hypotenuse, which is 10.21. we end up with V initial in the y is equal to 5.856. All right, so our V initial in the y is 5.856. Let's move this over. 5.856. Now we can do it again with cosine. So cosine of 35 times our hypotenuse. Oops. Don't quite know what I did here. Okay. We're going to get 8.36 meters per second, right? So we know that at the V initial and the x never changed because there's nothing accelerating it, only gravity's moving it up or down, right? So we can use acceleration equals V final minus V initial over time, where we plug in V final as 0, V initial as 5.85, wait, 5.856, right? Over the time, which we don't know. And we know that it was accelerating at 9.81 meters per second. Now we're working in 1D kinematic because we're working with only the y, so we're going to use our negative. So let's go ahead. Let's do a little bit of math. T equals negative 5.856 over 9.81. So if we were to do this, we would get math frac 5.856 over 9.81. This is a negative. Sorry, I dropped it again. So our time is equal to 0.596, which is half of the time it took us to get all the way across, right? It's more or less half of the time it took us to get across, and that's because it's a perfect parabola. So this is the time for max height. Now we can use this information that we just learned to plug in to our displacement. So D equals V naught T plus half AT squared, right? We can plug into here. We know that our V initial in the X was, in the Y was 5.856 plus half 9.81. And we know that it was moving for 0.596 squared, right? So if we were to plug this all in to get our displacement, we know that this is a negative 9.81. Let's go ahead, let's plug it in. We have 5.856 plus 0.5 times negative 9.81 times the time, delete, squared. We're going to end up with the displacement was 4.1081 meters for the max height. So the max height that this balloon reached was 4.108 meters, which means this kid threw this very high. And that would be everything for 2D kinematics. I know it seems overwhelming, but with a little bit of practice, I'm sure you're more than likely to get it. Okay? We're going to do number 3 now, because number 2 is the same thing. So go ahead and practice that one. Okay? So for number 2, you can do these either way. Remember, you could use all of these either using kinematics or using either 1D kinematics or breaking it into components, or using vector addition. So I'm going to do this one using vector addition. So this top one was triangle method. This is going to be component method. I'm going to guess how to spell components. I think that's right. Okay. So we're going to start with the same thing. We draw it out. There's a plane. It looks like a shark always. Sorry, I'm not an artist. It goes this way, right? And then it drops a box, right? If this box drops, it's going to end up moving left and down, or right and down, sorry. So let's make a motion map. I'm going to make positive up, negative down. You can choose either way. And it's going to start horizontal, and then as gravity affects it, it's going to start to speed up until it hits the ground. Let's write out all our knowns. Unknowns, we know that it is originally moving at 100 meters per second. That's our V initial. And we know that we start at a height. So max height for this one is 300 meters. We need to know our V final. Our acceleration, we know this is in free fall, so 9.81 meters per second. What else do we need? We need our time to hit the floor. We need to know that is about it, right? Yes, I believe that's it. Oh, our displacement and our total displacement. Okay, so what we're going to do first is we're going to break this into components. This one's simple because if the plane was moving completely horizontally, that means that the V initial in the X, that's not a good color to use because we already used that. Why do I keep picking the same colors? Okay, V initial in the X was 100 meters per second. And our V initial in the Y was 0 because it was moving completely horizontally. Now, there's no acceleration in the X. This is acceleration in the Y. Acceleration in the X would be 0. So what we're going to do is we're going to find out if this fell 300 meters, how long did it take to hit the floor? How can we do that? Using our acceleration formula. Acceleration equals V final minus V initial over time. Let's do these all in the Y. The time is total. That's not changing. Right? So we have 9.81 negative, right? Because we're moving downward. So 9.81 negative. And then we're saying that our V final, we don't know it. That's what we're looking for. We don't know our time either. So maybe we should start with our displacement, actually. Let's try our displacement. So displacement is V naught t plus half a t squared. V initial was 0 in the Y because these are all in the Y. We know that displacement in the Y was 300, right? Because it went straight down. And then we know that half negative 9.81, and we don't know our t squared, but we can solve for that easy. Let's go ahead. This ends up being 600 over negative 9.81, right? Equals t squared. We're going to square root. Time ends up being, so second square root, math frac, 600 divided by, divided by negative 9.1. Oh, this is a negative 300. Sorry, so these cancel. This is negative because you're going down. So we're going to end up traveling for 7.8206 seconds. Okay? So that's how long it took this box to hit the floor. Now, if we wanted to, go back. Sorry. So that would be how long it took to hit the floor. So now we can solve for the final velocity when it hit the floor in the Y. So V final in the Y is equal to change in velocity. Or actually, let's do this. Let's do acceleration in the Y. So 9.81 is equal to V final, which we don't know, minus 0 in the Y, right? Over the 7.8206 seconds it took to hit the floor. So now we're going to go ahead. We're going to multiply it over. So we're going to end up with 9.81 times 7. This is using, I'm going to write this just in case. V final minus V initial over T, Y, Y, Y. Right? So 7.8206. So So we're going to multiply that by the negative 9.81, and we're going to get that our V final is equal to negative 76.72 meters per second. Okay? So V final equals negative 76.72 meters per second in the Y. So to get the total V final, we can use Pythagorean theorem. If we know we're moving down at 76.72 meters per second, and our velocity in the x never changed, it's still 100, we can go ahead and we can solve for our V final total using Pythagorean theorem. So it's going to be 76.72 squared plus 100 squared, right? And then we're going to go ahead and we're going to square root that. Ooh, what is that? Second square root. And we're going to end up with our final velocity total was equal to 126.03 meters per second. That was our total V final. Now, we can do the same exact thing to find our displacement in the x, right? So we know now we can use the same exact component method to solve for the displacement in the x. So we were able to solve for V final total, right? So our V final here was 126.03 meters per second. And our time was 7.8206. Now we're only missing our displacement. We have literally everything else. So to solve for our displacement is V naught t plus half a t squared, right? So the displacement is V naught t plus half a t squared. And using that, we're going to go ahead and plug in. This is going to be in the x. We know there's no acceleration in the x, right? So it goes to 0. There's no acceleration in the x in free fall. Right, so I keep repeating this, but I haven't written it, so I'm writing it just in case. Okay, so we know that our V initial in the x, so we're looking for displacement in the x. We know our V initial in the x was 100, and we know we were falling for 7.8206 seconds, right? So that means that our displacement in the x was equal to 782.06 meters. Right, so to find our displacement total, we do the same exact thing. We're going to go ahead, put it back together. We know that in the x, we traveled 782.06, and we know that in the y, we traveled 300, right? So using that, we're going to use, so this is our displacement in the x. I put that in the wrong place. Displacement in the x. This is displacement in the y. So we're going to go ahead. We're going to solve for a total displacement. Same thing. 782.06 squared plus 300 squared equals d total squared. Right? So let's go ahead. Let's do Pythagorean theorem. We're going to have 782.06 squared plus 300 squared. Plug that into our calculator, and we're going to end up saying that our total displacement was equal to 837.626 meters. That is how far this package traveled, so it would be this total displacement here. Okay, so that's pretty much all the information that we can solve for this problem and everything that we needed to solve for. 837.626. Now, you might have noticed that I didn't graph any of these problems. And the reason you can't graph is because you would have to graph both the x components and the y components separately. You can't put them together. That would be like a 3D graph, which we don't work with. So don't even worry about graphing when it comes to 2D motion. That's more of a 1D motion. Okay? When with 2D motion, it would be more derivatives, but we'll learn that in the future. So this is the two problems that I went in the two method. We have the triangle method that we did first. We have the component method that we did second. These two methods work for any single problem. I usually use the triangle method because, as you noticed, it's a bit of a shortcut. It moves a little faster. It's a little more intuitive versus breaking everything down and then having to put it all back together. Okay, so go ahead and try all the other problems. I'll be posting the solutions soon. And if you have any questions, feel free to message me through email or through Remind. If you need any more video solutions, let me know and I'll record some more. Okay? Have a great summer, guys.